example number 5.11, which is, let me so here is question number example number 5.11. so we have been given cost C1 C2 is equal to $9, C3 $16, and sigma 1, sigma 2 and sigma 3, the standard deviation is given, and then we have the budget of $500 to be spent for the sampling. So we have to choose a right sample size and the allocation that minimize the variance. So the allocation we have already selected according to the our problem, which of course it has been calculated in example number 5.7, and A1 is 0.23, A2 is 0.387, and A3 is 0.290. so all these costs are allocations is mentioned, and we know already from the so N1 is the sample size from strata 1 and C1 is the cost, N2 is the sample size from strata 2, C2 is the cost, N3 is the sample size and C3 is the cost. So altogether we have $500 for this sampling process. So now we know that N1 is equal to NA1, N2 is equal to NA2, N3 is equal to NA3. So we replace the value of each N1, N2 and N3 with NA1, NA2 and NA3. So we have replaced all those values and we have obtained N into what is C1 is $9 and A1 is 0.323, and we have C2 is also $9 and A2 is 0.387, and plus $16 is C3 multiplied by A3. What is A3? 90. And we have taken out N already because N is part of every, so we have taken this N out, okay, by this way, and all is equal to $500. Okay, so now we'll try to estimate what is the final answer. 9 multiplied by 0.323, 9 multiplied by 0.387 plus 16 point, so final answer here 1103, $500. so N is equal to 500 divided by 11.03, 4533. so that is N. So it means that N1 is N of A1. So we have 45.33 multiplied by A1 is 0.3323. What is A1? 1.64. So approximately 15. So similarly you will calculate N2 with NA2. so N is already 15.33 multiplied by A2, which is 0.8, sorry 0.387. So what is the answer? N2 17.54. so approximately it is 18, and N3 is equal to NA3, so 45.33 multiplied by 0.290. so it is also equivalent to like 14 something 14, so it is equal to almost 13. So that is the allocations. Okay, so for example, if you would like to estimate A1, so what is the formula for A1, the proportional allocation? N1 proportional allocation formula. Now for you have to find the allocation for each of the allocation A1, A2 and A3, okay, by changing the numerator. So by using this information, because we have already been given sigma 1, sigma 2, sigma 3, C1, C2, C3, so it means that you can calculate the allocations by yourself. Okay, so if in this question is complete question, okay, so it means that only you will be given here N1, capital N1, capital N2 and N3, then you will be able to calculate the all the A1, A2 and A3, because you have already C1, C2, C3, so you have already sigmas. It means that you just need N1, N2 and N3. So when N2 and 3 and N1, N2 and 3 will be there, so you could easily calculate the A1, A2 and A3. Okay, so these allocation you have to estimate by yourself when the question comes, okay, by using the formula which I have mentioned. Rest is easy. That's so. In this example, we have calculated the proportion by using this information, and for each of the proportion, these proportion will be used where in the formula to estimate this proportion. Okay, to estimate this proportion, we will use all these P1, P2, P4. How? Let's go to the formula. I'll show you. So this formula will be used to estimate the proportion when your proportion is given in the form of statas. So you have been given P1 hat, P2 hat, P3 hat. So you will be placing all those values here. Because you have N1, you have P1, you have N2, P2 until P4. Okay, and then finally, so this N square should not be here. Okay, don't use this N square, only use this N, 1 over N. Okay, because this question is not relating with the variance, this question is relating with the average, so only 1 over N is needed, so rest is here. Okay, so here don't use this N square, only 1 over N, rest is okay. Okay, 1 over N, N1, P1, N2, P2 and so on until P4. You will expand this formula, put all the values, you will come up with the proportion. Okay, this proportion.
Related to average?
Yeah, this is the average proportion. This is proportion, this is the estimate of the proportion, but the average proportion of from all the stratas. Okay, average proportion. And after estimating the proportion, you will estimate the variance on the estimator, variance of the estimate, that is usually called the by taking the square root will get the standard error. Okay, so variance of the estimator is 1 over N square, n1 square variance of P1. So variance of P2 and variance of P3. So what we need to do, we will be using the same P, the P1, P2, P3, P4 to get the variance, okay, by putting here, because you will see, you can see here P1 and Q1. So P, the reverse of P is Q. Okay, so you will expand this formula until 4 values. Okay, and then the same P1, P2, P3, P4 will be used in this formula to get the variance. So once you have the variance, take the square root of that variance and multiply by 2 to get the bound on error. That is called the B. Okay, that is the B. 2 into variance of the estimator is called the B. Okay, and the main thing is mentioned in the table that is provided in the Excel. So let me make it part of the record. 5.14, 5.13, 5.10, 5.6 A part, 5.5, 5.2 and 5.1.